Okay, hello everyone. So today we're gonna finish the Pascal grade 9 questions from last time that we didn't finish, and then we're gonna talk about some 离散数学, which I'm gonna explain in Chinese afterwards. Okay, so number 16. If x is a number less than -2, which of the following expressions has the least value? Yeah, this is the last meeting. So for number 16, we can see that all of the options is basically, we can express them as functions. So fx equals something. Like for a, we could do fx equals x, and then x is less than -2. And then fx is also y. So a is y equals x, b would be y equals x plus 2, and so on. And then we would be able to graph out the functions and put them in a chart, which would look something like this. So we can see that the red one is fx equals x, and then x is less than -2. So this would be option A. And then on the graph, we can see that it is the red function, which is the straight line over here. And then blue would be B, green would be C, purple would be D, and black would be E. So now all we have to do is see which function has the least value for the y-axis, because fx equals y. So we can tell that clearly the black function, or the black line over here, has the least value for all of the possible values of x. And then the black function is jx equals 2x. So E would be the expression that has the least value, and then we choose E. Another way to do this would be just to find a random number less than -2 and put it into each of the options and then see which one is the least. Number 17. Hagrid has 100 animals. Among these animals, each is either striped or spotted, but not both. Each has either wings or horns, but not both. There are 28 striped animals with wings. There are 62 spotted animals, and there are 36 animals with horns. How many of Hagrid's spotted animals have horns? Okay, for this, we can put out a chart. And then we can label it like striped, spotted, wings, and horns. And then we can fill in the information that we have so far, which is the only one that we can put in is 28 striped with wings. And then the other ones we are not sure yet. So we know that there are 62 spotted animals. So for the column of spotted, there are 62 in total. And then there are 36 animals with horns. So for the line of horns, there are 36 in total. And then we also know that there are 100 animals in total. So we can figure out the rest of the places in the chart. So we can start with knowing that there are the amount of animals that are striped with horns. So because we know that there are 100 animals in total, and then, we know what the total striped animals, how many there are, by subtracting 62 from 100. So 100 minus 62 would be the column of the striped animals, and that would be 38. And then we know that there are 28 striped with wings, so we do 38 minus 28, which is 10, and then that would be the amount of animals that are striped and have horns. And then we know that the total amount of animals who have horns is 36, so we do 36 minus 10. This equals 26. So that means that there are 26 spotted animals with horns. And then for the last place, we know that there are 62 spotted animals in total. So 62 minus 26. That would be the animals that are spotted with wings. And then this equals 36. So there would be 36 here. And then it asks how many of Hagrid's spotted animals have horns. So we want to know the answer in this place, and then it would be 26. So Hagrid has 26 spotted animals with horns, and we choose E. Number 18. In the diagram, each of triangle QPT, triangle QTS, and triangle QSR is an isosceles right-angled triangle, with angle QPT equals angle QTS equals angle QSR equals 90 degrees. The combined area of the three triangles is 56. If QP equals PT equals K, what is the value of K? So first, we can use the Pythagorean theorem to figure out what QT and QS are. And then after we know that, we can figure out the areas of the three triangles, because we know that their combined area is 56. And then we can figure out the value of K. So first, if we look at the smallest triangle on the left, triangle QPT, the right angled sides are K, which is QP and PT. So this means that QT squared equals K squared plus K squared, which equals 2K squared. And then for the triangle in the middle, we could see that the right angle sides are QT and TS, but they are equal to each other because triangle QSR is, or triangle QTS is an isosceles triangle. So we know that QS squared equals QT squared plus QT squared because QT equals TS. So this means that it would equal, because QT we found out over here equals 2K squared, so this would equal 2K squared plus 2K squared, which is 4K squared. And then after knowing what QT squared and QS squared is, we can figure out what K is. So if we add all of the surface areas of the three triangles, it would look something like this. So for the smallest triangle, it would be the base times height divided by 2, and the base and the height are both K, so it would be K squared divided by 2. And then plus the surface area of the middle triangle. For that, the base would equal TS, which equals QT. So base times height would just be QT squared. And then we know that QT squared is 2K squared, so we can just do 2K squared and then divided by 2. For the last triangle, the biggest triangle, the surface area is also base times height divided by 2. And then the base times height is RS times QS. But RS and QS are the same, so it equals QS squared. And then QS squared equals 4K squared. So this would be 4K squared divided by 2. And then this whole thing would equal 7K squared over 2. And then we know that the combined area of the three triangles is 56. So 7K over 2 equals 56. And then we solve for K. 7K squared equals 56 times 2 equals 112. And then K squared equals 112 divided by 7 equals 16. And then K would be the square root of 16, which is 4. So the value of K would be 4. And then we choose C. Number 19. There are 6 identical red balls and 3 identical green balls in a pail. 4 of these balls are selected at random, and then these 4 balls are arranged in a line in some order. How many different looking arrangements are possible? So we know that 4 of the balls are selected at random, and then we can discuss what the different situations could be. So the random balls could be 4 red balls, and then the only way to arrange them would be red, 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 red. Another situation would be there are 3 red balls and 1 green ball, and then this could be red, 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 green, red, red, green, red, red, green, red, red, green, red, red, red. And then for 2 red and 2 green, it could be red, red, green, green, red, green, red, green, red, green, green, red, green, red, red, green, green, red, green, red, and green, green, red, red. And then after that, we could have 1 red and 3 greens. Then it could be red, green, 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 red, green, 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 red, green, or green, 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 red. And then after that, we can't have 4 green balls because there are only 3 green balls in total. So these are the only possible different arrangements, and then we see how many there are. So when there's 4 red balls, there's 1, and then 3 red and 1 green, there are 4, and then there plus 6 plus 4, and then that would be 15. So there would be 15 different looking arrangements. And then we choose A. Number 20. In the diagram, square PQRS has side length 40. Points J, K, L, and M are on the sides of PQRS as shown, so that JQ equals KR equals LS equals NP equals 10. Line segments JZ, KW, LX, and MY are drawn parallel to the diagonals of the square, so that W is on JZ, X is on KW, Y is on LX, and Z is on MY. What is the area of quadrilateral WXYZ? So we know that the square PQRS had side lengths 40, and then JQ, KR, LS, and MP all equal 10. So this would be 10, and this would also be 10. And then this QR would be 40. And then we're trying to figure out the surface area of the shaded quadrilateral in the middle. So first, we could extend KW to PQ, and then name the place where they meet, say that they intersect at N, and then we connect MN. And then because NK is parallel to PR, which is one of the diagonals of square PQRS, that means angle QNK equals angle QKN equals 45 degrees, because that we know that the diagonal of a square, like the angles where it meets the sides, are 45 degrees. So because NK is parallel with PR, then the angles where it meets with QP and QR would also equal 45 degrees. And then we know that QN equals QK equals 40 minus 10 equals 30. We know that Qn equals Qk because the two angles at the bottom are both 45 degrees, which means that it would be an isosceles triangle. And then we know that Qk would just be Qr minus Kr, so 40 minus 10, which is 30. And then we would know that Pn equals 40 minus 30, which equals 10, because Pn is Pq minus Nq. And then lastly, we could know that Nm is parallel to Qs and Nm equals Wz. Nm is parallel with Qs, which is the other diagonal of the square PQRS, and Nm equals Wz, which is one of the sides of the quadrilateral that we are trying to solve. And then we're guessing that the quadrilateral is a square, so we need to prove that. Or we also need to find what Wx or Zy equals. So for that, we can extend Lx to Qr, and this intersects at T. And then we connect JT. So similarly, JT would be parallel with PR, and JT would equal Wx because it is symmetrical with NK and with Mn over here that we proved just now. And then because PM equals Qj equals Qs equals 10, so the PM, Pn, Qj, and Qs all equals 10. So Mn equals Jt, which equals the square root of 10 squared plus 10 squared. We can get this from the Pythagorean theorem because we know that the four corners of a square are all right angled, and then the two sides of the triangle are both the sides of the right angle triangle are 10. So Mn and Jt would equal the square root of 10 squared plus 10 squared, which is the square root of 200. And then the surface area of quadrilateral Wxyz equals Wz times Wx, so this side plus this side, and then this equals Mn times St because we proved, Jt, because here we proved that Mn equals Jt, and over here Nm equals Wz, and then this would equal the square root of 200 times the square root of 200, which equals 200. So the area of quadrilateral Wxyz would equal 200, and we choose B. Part C, number 21. What is the units ones digit of the integer equal to 5 to the power of 2019 minus 3 to the power of 2019? So for this, we first observe the patterns of the powers of 5 and the powers of 3. So 5 to the power of 1 would equal 5. 5 to the power of 2 would equal something on the tens digit and 5 on the ones digit, because 5 times 5 would be 25. And then 5 to the power of 3 would be something, and 5 on the ones digit, because on the ones digit it would be 5 times 5, which would still be a 5 on the ones digit, and then so on. We can see that 5 to an integer power would have a unit digit of 5. And then for 3 to the power of 1 equals 3. 3 to the power of 2 equals 9. 3 to the power of 3 equals something with a ones digit is 7. 3 to the power of 4 equals something 1. And then 3 to the power of 5 equals something 3 again. So we can see that for the 3 to the power of 5 and 3 to the power of 1, both have a ones digit of 3. And then we can suspect that there is a pattern or a loop. And then we continue for a bit. 3 to the power of 6 equals something 9, because over here 3 times 3 would give us a ones digit of 9 still. And then 3 to the power of 7 would be something 7, because 9 times 3 would have a ones digit of 7. And then 3 to the power of 8 would be something 1. So we know that there is a loop of 3971 on the ones digit, and there would be a loop every 4 numbers. So we want to know which ones digit the 2019th power would be. So we do 2019 divided by 4. If this has a remainder of 1, then it would have a units digit of 3. If it has a remainder of 2, it would have a unit digit of 9. If it has a remainder of 3, it would have a units digit of 7. And if it doesn't have any remainders, it would have a units digit of 1. And then if we calculate this, this would equal 504, remainder 3. So that means that 3 to the power of 2019 has a ones digit of 7. So 5 to the power of 2019 minus 3 to the power of 2019 would be something with a ones digit of 5 minus something with a ones digit of 7. And then if we calculate this, 5 minus 7 would be smaller than 0, so we would have to make it 15 minus 7. And that would mean that the number would have a ones digit of 8. So the units ones digit of the integer equal to 5 to the power of 2019 minus 3 to the power of 2019 would be 8. And then we choose E. Number 22. The integer 2019 can be formed by placing two consecutive two-digit positive integers 19 and 20 in decreasing order. What is the sum of all 4-digit positive integers greater than 2019 that can be formed in this way? So we can list out the sum of the integers all the way to the last integer. So it would start from 2120 and then end at 9998, which is the biggest this type of 4-digit positive integer. And then we can notice that all of the terms in this sequence has a difference of 101, because 2120 plus 101 equals 2221, and so on. So this would be an arithmetic sequence, and then if we want to find the sum of some of the terms in the arithmetic sequence, we can use this formula. Sn equals n times a1 plus an divided by 2. So over here, n would be the amount of terms in the sequence in total. So we know that it ends at 9998, starts at 2120, So there would be 99 minus 21 plus 1 amount of terms in the sequence. We have to plus 1 because we always plus 1 when we want to see how many there are in between two numbers. And then this times A1 is the first term in the sequence, which is 2120. And then AN is the last one. The nth is the last one because we want it to be all the way to the last one. So it would be 9998, and then this divided by 2. This would equal 79 times 12118 over 2, and then this equals 79 times 6059, and this equals 478661. So the sum of all 4-digit positive integers greater than 2019 that can be formed in this way would be 478,661, and then we choose C. Number 23. A path of length 14 meter consists of 7 unshaded stripes, each of length 1 meter, alternating with 7 shaded stripes, each of length 1 meter. A circular wheel of radius 2 meters is divided into 4 quarters, which are alternately shaded and unshaded. The wheel rolls at a constant speed along the path from the starting position shown. The wheel makes exactly 1 complete revolution. The percentage of time during which a shaded section of the wheel is touching a shaded part of the path is closest to. So first, because the wheel isn't really big, we can draw out the rest of the path. So it's alternating between shaded and unshaded. So these would be shaded. And then we can say that this is 0 meters, 1 meter, 2 meter, 3 meters, 4 meters, 5 meters, and then 6, 7, 8, 9, 10, 11, 12, and 13. Okay, so now we can figure out the circumference of the wheel in order to know like how much it spins and everything. So the circumference would equal pi times d, the diameter. So 2 squared times pi, and then this equals 4 pi meters. And then we can label the wheel according to the circumference. So over here, this would be pi meters, this would be 2 pi meters, 3 pi meters, and 4 pi meters, which is also 0 meters. And then we can start to spin the wheel. So if it spins from 0 to pi meters, we know that pi is between 3 and 4, so it can stop somewhere around here. And then when the shaded part touches a shaded part, would be from all the way from here to and 3 to pi. And then the wheel rolls from pi to 2 pi, and then we know that 2 pi would be in between 6 and 7. So we can say that it stops there. But on the wheel, it doesn't have any shaded sections, so we can ignore this whole part. And then it rolls from 2 pi to 3 pi. 3 pi would be somewhere in between 9 and 10. So we can say that it stops over here. And then 2 pi to 3 pi on the wheel is shaded, so we have to count the parts when the shaded section is touching a shaded section. So we have to count from 7 to 8 and between 9 and 3 pi. And then lastly, the wheel rolls from 3 pi to 4 pi, and then we know that 4 pi is in between 12 and 13, so it stops somewhere around here. And that is the whole revolution, which is one complete circle. So we know that from 3 pi to 4 pi, the wheel doesn't have any shaded parts, so we don't have to count any of that. And then we can calculate how much the percentage of the shaded part of the path to the total length of the path that the wheel passed. So between 1 and 2, we need to count this part, which is a shaded section plus a shaded section. So 1 plus over here, it was pi minus 3 pi, or pi minus 3. And then we add the part in between 7 and 8, which is 1. And then this part from 3 pi minus 9. And then those are all of the parts when the shaded section of the wheel is touching a shaded part of the path. And then the total amount of the path that the wheel passed would be 4 pi, which is the circumference of the wheel. And then this would be 4 pi minus 10 over 4 pi, which equals 2 pi minus 5 over 2 pi. And then this isn't an integer, and it asks us what it is closest to. So this is approximately 0.20, which is 20%. And then, so now we know that the percentage of the path that a shaded section of the wheel is touching a shaded part of the path. So, but it asks us for the time. But for this question, the percentage of the time is equal to the percentage of the distance, because it says that the wheel rolls at a constant speed along the path. So it would be the same. And then we figure out the percentage of the distance where a shaded section is touching a shaded section of the path. And then that would be 20%. So we choose A. Number 24. If P, Q, R, S are digits, how many of the 14-digit positive integers of the form 88663311 PQRS48 are divisible by 792? So first, we can notice that 8866331100 divided by 792 is an whole number, is an integer, which equals 111948625. So from this, we also know that if we add more zeros onto 8866331100, like if we add 3 more zeros, it can still be divisible by 792. We just need to add the same amount of zeros onto the answer. So we know that 88663311 with however many amount of zeros at the end are all divisible by 792. This means that we only need to find out how many of PQRS48 are divisible by 792. So this would be from 000048 all the way to 999948. And then it says that it is divisible by 792, so we can say that 792 times n equals PQRS48. And then obviously their n has a biggest value and a smallest value. So n, the smallest value for n would be 1, because 1 times 792 would equal 792, and it is in between 48 and 999948. And then we need to see what the biggest n would be. We would do 999948 divided by 792. This would equal 1262, remainder 444. So we know that the biggest possible value for n would be 1262. If n were to equal 1268, then the multiple of 792 would be bigger than 999948. So it wouldn't be possible. And then now we have this equation which says 792n equals PQRS48. In order for PQRS48 to be divisible by 792, we need 2 times n to equal 8. And then the only possibilities of that is when n ends in ones digit of 4, so 2 times 4 equals 8, or when n has a ones digit of 9, because 2 times 9 would equal 18. So there are only 2 situations for this. One is when n equals 10c plus 4, or when n equals 10c plus 9. And then over here, the c just determines the tens digit of the n, because n could be 4 or 14 or 24 or 34 and so on. And then for c, it just has to be greater than or equal to 0, because it could be 0 and n would just be 4 or 9. And then we discuss these 2 situations. The first one is when n equals 10c plus 4. This means that 792n would equal 7,920c plus 3,168, because we know that 792n equals n equals 10c plus 4, so 792n would equal that. And then we know that the 2 times n would equal 8, so the ones digit would be an 8. We also need the tens digit to be a 4, so 792n has to have a ones digit of 4. So over here, the 792n equals 7,920c plus 3,168. So this needs to have a tens digit of 4. So this means that 2 times c plus 6 equals 4 or 14 or 24, and so on. So 2c plus 6 equals 4, 14, 24, and so on. And then because有一个什么叫 hello。 今天我有9个学生，好像前面有一个 ky 什么，上次差点移除了，必须的。Calvin, C-N-E, Vivian. Okay, so 2c plus 6 equals 4, 14, 24, and so on. This means that c would equal 1, 6, 11, 16, 21, 26, and so on. And then because n equals 10c plus 9, this would equal 19, 69, 119, 169, 219, 269, so on, all the way to 1119, 1169, 1219, because n has the biggest value for n is 1262. So now we see how many values of n there are. Between 0 and 100, there are 2, which is 19 and 69. Between 100 and 200, there are also 2, which is 119 and 169. So there all the way to between 1100 and 1200, there are still two values of n. So there would be 12 of those 2's. And then for the last one, between 1200 and 1300, there's only one possible n, so plus 1. And then this would equal 25. And then there are 25 values of n. Oh wait, I did this wrong, and this is 10c plus 9. I did the n equals 10c plus 9 one first. And then for the other one, which is n equals 10c plus 4, this would be 792n equals 7920c plus 3168. And then over here, this was 7,128. Yeah. And then, so for the n equals 10c plus 4, 792n equals 7,920c plus 3,168. So we also want, for this situation, 792n to equal PQRS48, which has a tens digit of 4. So 2 times c plus 6 equals 4, 14, 24. For this one, oh wait, yeah, this is also 4, 14, 24. So for this one, 2c plus 2 equals 4, 14, 24, and so on. And then for the c, it would equal 4, 9, 14, 19, 24, 29, 34, 39, and so on. And then because n equals 10c plus 4, then n would equal 44, 94, 144, 194, 244, all the way to 1194 and 1244. And then we need to see how many values of n there are. So for this one, between 1 and 100 there are 2, between 100 and 200 there are 2, between 200 and 300 there are 2. And the last range that has 2 is 1100 to 1200. So it is basically the same as when n equals 10c plus 9. There are 12 2's. And then for the last one, which is in between 1200 and 1300, there is only one value of n. So for n equals 10c plus 4, there are also 25 values of n. And then it asks for how many of those 88663311 PQRS48 are divisible by 792, which is how many values of n there are. So there would be 25 plus 25, which is 50 values of n. So there would be 50 PQRS48 and 50 88663311 PQRS48 that are divisible by 792, and then we choose E. Number 25. In the diagram, PR and QS intersect at V. Also, W is on PV, U is on PS, and T is on PQ, with QU and ST passing through W. For some real number x, the area of triangle PUW equals 4x plus 4. The area of triangle SUW equals 2x plus 20. The area of triangle SVW equals 5x plus 20. The area of triangle SVR equals 5x plus 11. The area of triangle QVR equals 8x plus 32. And the area of triangle QVW equals 8x plus 50. And it asks, the area of triangle PTW is closest to. So we can label the triangles that it told us. So this would be 1, 2, 3, all the way to 6. And then on the diagram, it would be like 1, 2, 3, 4, 5, and 6. For triangle QTW and PTW, they don't tell us what, for some real number x, what it equals, so we can make this y and z. And for this question, triangle PTW, so we are looking for z. And then for this question, we also need to know something. So in a triangle, if we split it into two triangles like this, we make this S1 and this one S2. This is A, and this, like the base, are A and B. Then S1 over S2 would equal A over B because their height is the same. We can also prove it because S1 over S2 would be base times height divided by 2, so AH divided by 2 over BH divided by 2. Then this equals AH over 2 times 2 over BH, and then we can cross out the 2's and the h's, so this gives us A over B. So S1 over S2 would equal A over B. So we can use this into our diagram over here. We know that if two triangles have the same line segment as their base and has the same height, then we can use this equation over here. And then we just look for those in the diagram. So the first one we can find is S6 over S3 equals S5 over S4. So 6 and 3 over here could be with 5 and 4 because they both have the same sides for the base, which is QV and SV. And then we just put in the values of x for over here for some real number x, and then put in these values and then solve for x. So there would be 8x plus 50 over 5x plus 20, which is S6 over S3, would equal 8x plus 32 over 5x plus 11. And then we solve for x. And then we can do this on a separate sheet of lined paper. So I'll just use the next slide, which is the cover for the 离散数学 part. Okay, so if we do for the equation that we had, we know that if we multiply it across, like 5x plus 20 times 8x plus 32, we multiply those, and we also multiply 8x plus 50 and 5x plus 11, their product would equal each other. So 5x plus 20 times 8x plus 32 equals 8x plus 50 times 5x plus 11. And then we take out the brackets, it would be 40x squared plus 160x plus 160x plus 640 equals 40x squared plus 250x plus 88x plus 550. And then simplify that, so 320x plus 640 equals 338x plus 550, and then 18x equals 90, x equals 90 over 18 equals 10 over 2 equals 5. So now we know that x equals 5, which is the solve for the equation that we put. And then we can figure out the actual area of the triangles 1 to 6. So triangle PUW is 4x plus 4, so 4 times 5 plus 4, which is 20 plus 4 equals 24. And then triangle SUW would be 10 plus 20, which is 30. 5x plus 20 is 25 plus 20 equals 45. And then the rest would be 36, 72, and 90. And then we know what the areas of the triangles 1 to 6 would be. Now we just need to figure out triangles y and z. And then we can still use the equation over here, which is S1 over S2 equals A over B. But we just need to find triangles that involve y and z. So for this one, we can do it like this. We need to find two pairs because there are like two unknown numbers. So SZ over S1 plus S2 equals SY over S6 plus S3. This equals TW over SW, just to prove that they are actually equal. And then for the second one, we could do SZ plus SY over S6. This equals S1 plus S2 over S3. And then this would equal PW over VW. So for the first one, SZ and S1 and S2 would be from the triangle PTS. And then SY and S6 and S3 are from the triangle QTS, and they both share the side TS. So we can make them equal each other, which is the A and the B in the equation over here. For the second equation, SZ, SY, and S6 are all part of triangle PQV. S1, S2, and S3 over here are all part of triangle PVS. So they both share the side PV, which is made up of PW and VW, which are the A and the B in the equation. And then we put the actual values of S1, 2, 3, 4, 5, 6 into the equations, and it would be like SZ over 54 equals SY over 135. And SZ plus SY over 90 equals 54 over 45. And then we just solve for SZ and SY. But we don't have a lot of time, so I'm not going to show the process. And then in the end, we would get SY equals 540 over 7, and SZ would equal 216 over 7. And then SZ is the triangle PTW that we are trying to solve for, and it asks for a closest value again. And this is not a whole number, so we round it off. This is approximately 30.86, which is closest to 31. So the area of triangle PTW is closest to 31, and then we choose E. And then now I'm going to talk about some of the 离散数学的 stuff, and I'm going to speak it in Chinese. Yeah. And then we might need to make it a little bit past 6 o'clock. It's okay if some of you guys have to leave, but I'm gonna stay here. Yeah. So 我们要说离散数学是怎么覆盖竞赛题的，因为离散数学非常重要，并且我们做了很多的竞赛题，然后我们可以总结一些经验。我们先来看离散数学是什么。从内容上来看，离散数学没有一个确定的中心话题，内容很杂。粗略统计，其涉及到主要概念如集合、函数、关系、命题逻辑、 谓词逻辑到算法、技术、数据结构、递归、图论、概率、数论、形式语言与自动机、布尔代数、向量与矩阵、线性规划、抽象代数、编码理论、信息论、博弈论、运筹学、理论计算机科学等。真是那句俗话，某某某是个筐，什么都可以往里装，但它们都有一个共同的结构，即离散结构。离散数学并没有开辟数学的新领域，而只是在现有的数学上把由离散结构组成的数学对象汇成一个集合，是对数学的一个划分。Basically 就是离散数学很重要，然后包括所有这些列举出来的这些东西，离散结构。然后我们做了一个表，就是在我们所有这10次课里面讲过的8套题里面，有哪些题用到了哪些离散数学里面的知识点。上面的这些是从7年级2020一直到9年级2019，就是我们今天做完的这套。然后左边的第一列就是数理逻辑、数论、集合论、排列组合概率论和图论，是5个最重要并且在竞赛题里面出现的最频繁的一些离散数学的知识点。我们可以用这个表来观察一下它们是怎么分布的在这些竞赛题里面。我们先从数理逻辑开始，它在7年级2019的时候出现，7年级2018、7年级2017，这些在表格里面有题号的地方，这些就是那些出现的竞赛题里面的那些题号。然后我们可以发现，这个数理逻辑在出现的并不是非常的频繁，但是也有一些比较大的题用到了数理逻辑，比如说 Part C 里面的21题和23题。然后数论是离散数学里面最基础的一个知识点，它在这些竞赛题里面出现的比较频繁，并且有很多的大题都用到了这个，比如说25题，然后8年级2020里面的24、25，还有9年级的25题，在某一些小题上面14和13题里面也用到了数论的知识，这个是非常基础的一个知识。然后集合论非常出现的次数很少，但是出现的时候都是在最后的大题上面，比如说25题、25题和24题，然后17题也是比较难的一个题了，虽然不是最难的。所以这个集合论出现的时候就会是在考非常大的题，或者它不出现。然后排列组合概率论是出现的最频繁的知识点，从这个简单的题到难的题它都出现过，比如说14题、13题，还有24题、25题都出现了排列组合概率论，说明这个考的非常频繁，并且也有很多的大题也考了它。然后最后是图论，是一个并不是非常出现频繁的一个知识点。然后关于图论这个我们并不需要学得非常彻底，因为在竞赛题里面虽然出现了图论，但是不需要学过很扎实的图论也可以把那些题做出来，所以如果没有很多时间来学的话，并不需要这个专注在图论上面。然后我们再来看一下这个竞赛题，对于这些竞赛来说都是60分钟，所以我们可以这样子来分这个时间，比如说从第1题到第20题我们用20分钟，所以就是1分钟每道题。这些就是 Part A 和 Part B 里面最简单的那些题，所以我们需要尽快的做，并且不能做错任何。然后是从21到23，这个也用20分钟，这个时候就有每6分钟一道题。这个已经是 Part C 里面的比较简单的难题，然后我们每6分钟做一道题。 最后就是最难的2道题，24和25，也用20分钟，这个就有10分钟每道题。然后我们可以看出来，即使我们这样子来分布我们的时间，24和25题最多也只有10分钟。所以如果我们每道题都来自己建一个新的模型，会比较没有效率。所以我们需要60分钟无法创建解题的新模型，然后我们需要从教材中熟悉古典经典的模型，那样子我们在做题的时候就会更容易并且更有效率，就直接套那些模型就可以了。然后我们还从数理逻辑、数论、集合论、排列组合、概率论里面各选了1道题来举例，让大家知道这些知识点大概是什么样子的。对于数理逻辑，我们选的是2020年9年级的第19题，就是关于卡片，并且这些数字和字母的。它19题说这个15个卡片每张有一面是字母，另一面是正整数。然后如果我们想要看这个命题是否正确，需要最少翻开多少张卡。然后命题是，如果一张卡一面是小写字母，那么另一面就是基整数。然后我们知道这个就是一个非常经典的逆否命题，可以用到这个表。命题就是如果 P 那么 Q， 然后逆否命题就是如果不是 Q 那么不是 P。如果我们想要证明这个命题是对的，我们需要先翻开所有小写字母的牌，也就只有 E 这一张。然后这个还不够证明这个已经是所有的小写字母另一面都会是基整数，所以我们还需要翻开所有不是基整数的那些牌，也就是所有的偶整数。如果我们翻开所有的偶整数，并且发现另一面都不是小写字母的话，那么就可以证明这个原命题了。所以对于这道题来说，我们需要翻开所有的小写字母和所有的偶整数，也就是 E、60和88，然后最少我们就只需要翻开来3张卡，然后就能证明这个命题了。然后我们选 E。对于数论，我们选了2020年的Pascal 的9年级的第25题，就是说这个 m·n 正整数是一个 happy pair， 如果它们的最大公因数是一个完全平方数。比如说20和24是一个 happy pair， 因为它们的最大公因数是4。假设 k 是一个正整数，让205800·35k 是一个 happy pair，这些 k 小于等于2940的所有可能的 k 的值是多少？这个就是数论，因为学到了或者考到了这个质因数分解，我们需要质因数分解205800和35k， 然后看这个 k 是哪些质数的和的时候，或者质数的积的时候，可以让它们的最大公因数是一个完全平方数就可以了。然后还需要知道这些质因数，这些就是质因数都必须是一个偶数次项或者偶数次幂，才能让这个最大公因数是一个完全平方数。然后这边我们不能具体的解那个题。然后集合论就是选的是7年级2017年的25题。Ashley 把前2017个正整数写出来了，他下划了任何2的倍数、3的倍数和5的倍数，最后 Ashley 找到了所有那些没有被下划了的整数的和。这个和是什么？这个就是集合论，因为我们可以 来做一个集合，来代表所有的这些情况。比如说这个最大的框子就是所有的2017个正整数，然后我们再做3个集合，就是2的倍数、3的倍数和5的倍数，然后我们就可以来找到这些圆圈的这些集合之外的所有的这些项，它们是有多少个，然后我们再用容式原理来看它们的和是多少，然后所以这个需要用到这些集合论里面的知识。然后这个排列组合概率论选的是2018年的7年级的25题，在这个三角形里面1、2、3、4、5、6、7、8被放到了一个不同的圈里面，然后这个三角形的3条不同的边的和都等于同一个数字 s， 这些所有可能的不同的 s 的值是多少，就是让我们求出来所有可能的 s。 然后这个时候是排列组合和概率论，就是看我们把这些数字1、2、3、4、5、6、7、8怎么排列组合到这个图里面去。然后这道题我们可以来设 A、B、C、D、E、F、G 和 H， 那样子我们就知道，因为 S 就是每条边这些的和，所以 3S 就等于 A 加 B 加 C 加 D 加 D 加 E 加 F 加 F 加 G 加 H， 然后加 A， 然后这些因为我们知道 A B C D F G 就是1、2、3、4、5、6、7、8，我们就可以得出来 3S 是一个值，然后算出来 S 最终就只有14、15、16、17、18和19是可能的 S， 然后我们再看这些 S 里面有多少个我们可以真正的排列组合出来一个这样子的图，用1、2、3、4、5、6、7、8放在这些圆里面，然后就可以做出来了。然后这个就是最后一个例子，我们还做了一个学习路线，比如说我们想学离散数学里面的一个知识点应该从什么开始学，然后需要看右边的这个图和左边的这个数字的目录。比如说我们想要学数论和密码学，是一个比较热门的东西，我们就需要从第1章开始，就是从基础逻辑和证明开始，然后第2章就是集合函数序列求和与矩阵，到第3章算法，最后学数论和密码学，就是这样子的一个学习路线。然后如果我们想要学这个离散概率第7章，我们就需要从第1章开始，第2章、第3章、第4章、第5章、第6章，最后第7章，那样子才可以学懂这个离散概率是什么。然后比如说我们想要学计算模型第13章，就是第1章、第2章、第3章，然后第13章就可以了。然后这样子就是一些离散数学的知识点的一个学习路线。然后最后离散数学的知识点基本上就讲完了，然后这个是我们的最后一次课，然后希望大家都学到了一些新的东西。Does everyone think their math skills improved?
Yeah.
Okay, thank you everyone. So there's a slide for thank you.
Thank you.
Thank
Bye.
you. Bye.
Thank you. Bye.
Bye. Okay, have fun doing math, everyone. I'm gonna leave now. Oh yeah, your Mandarin also improved. My Mandarin improved from this too. Okay, bye everyone. Thank you.